In this video, I'll talk about 4 different strategies that you can use to evaluate limits algebraically. Our first example is the limit as x goes to 0 of 5x over 2 minus x. And the first strategy that we'll try is direct substitution. So I'm going to plug 0 right in, giving me 5 times 0 over 2 minus 0. In this case, that reduces to 0 divided by 2, which is just 0. That means the actual height of the function was the intended height of the function, and it was simple. In our second example, we'll see that direct substitution doesn't work. When I try to plug in 2, I get a 0 divided by 0, which is not something that we know how to evaluate. So it requires further investigation. What that means in this example is factoring. So I'll take the numerator of x squared minus 4 and I'll factor it to x minus 2 times x plus 2. The denominator of 2 minus x I'll factor by pulling out a negative 1, leaving it negative 1 times the quantity x minus 2. Now I see a common factor of x minus 2 in the numerator and denominator, and I cancel them out. And I read what's left of the limit. It's x plus 2 divided by negative 1, and now I'm ready to try substitution again. I sub in a 2, and I get 2 plus 2 divided by negative 1, which is 4 divided by negative 1, or negative 4. So in this one, we found the limit, even though direct substitution failed us. In our next example, we'll see yet another strategy. Here we have the limit as x goes to 2 of x minus 2 divided by something really ugly looking. When I try substitution, once again, I find that I get 0 in the numerator, 2 minus 2. And when I work out the denominator, I get the square root of 4 plus 12. That's square root of 16. It's 4 minus 4. Yeah, that gives you 0 in the denominator again. You'll see this 0 divided by 0 popping up all the time with limits. And it's usually indicating that there's a hole in the graph. You can figure out where that hole is just using your algebra. In this case, the algebra skill that you'll need isn't factoring, but it's using the conjugate. And you'll use this strategy very often when there's a square root involved in the problem. So the conjugate is, by design, it's making a difference of squares factoring problem. So it's created by changing the sign. In this case, a plus 4 instead of a minus 4. So when I want to multiply this out in order to simplify, one thing that I find is helpful is not bothering to do any multiplication in the numerator, leaving it x minus 2 times the quantity square root of 4 plus 3x squared plus 4. Multiplying that out won't actually help you. Multiplying out the denominator will help you, because the denominator is where we designed the conjugate. And you'll see why it's helpful. When I multiply the first 2 terms, the square root goes away, and the second 2 terms are easy to multiply. The outer and inner terms cancel by design. So I'm left with 4 plus 3x squared minus 16. I have to simplify further. And when I do, I'll just leave my numerator alone. And the denominator becomes 3x squared minus 12. I'm getting somewhere, but I'm not there yet. I continue to look at this and see how can I simplify. Now I'm going to utilize that factoring strategy. In the denominator, 3x squared minus 12 has a GCF of 3. And when we pull out the 3, I see I'm left with x squared minus 4. And now you can probably see where this is headed. X squared minus 4 can factor to x plus 2x minus 2. And now we are able to cancel that common factor of x minus 2 in the numerator and denominator and substitute in x equals 2 to what remains. When we do, just a little bit of arithmetic tells us that we're going to get 8 in the numerator and 12 in the denominator. And 8/12, of course, reduces to 2/3, just enough space for that. Okay, so now we've seen 3 strategies: substitution, factoring, and the conjugate. Our last strategy we'll see when we have fractions involved, and that's going to be getting a common denominator. So this time I tried direct substitution, and I don't see type 0 divided by 0 this time. Instead, what I see is 2 divided by 0 minus 8 divided by 0. So this actually indicates not a hole in the graph, but the individual fractions are asymptotic. So some sort of infinity minus infinity, which is super confusing. How do you evaluate infinity minus infinity? What it means is you need to investigate further. And the conjugate is just, or I'm sorry, the common denominator is just the tool that you'll need to use for further investigation. So our denominators have a common GCF of x minus 2, x plus 2. So I'll adjust the numerators, 2 times x plus 2 minus 4x. And then I'll distribute the 2 and continue to simplify. When I distribute the 2, I get 2x plus 4 minus 4x, which simplifies to negative 2x plus 4. I see that I have a common factor of negative 2 in the numerator that I can pull out. And when I do, once again, it leaves me that factor of x minus 2. Kind of common theme here, that the x minus 2 cancels. And that actually eliminates the 0 divided by 0 that we created once we got the common denominator. And now I can substitute in 2 to what remains. And I'm left with negative 2 divided by 2 plus 2, which of course is negative 2 divided by 4. And that's negative 1/2. So that was the 4 different strategies that you can use to evaluate limits algebraically. You can try substitution, and you should always try that first. Because if that works, you're done. And if it doesn't, it probably gives you a clue as where to go next. You can try factoring. You can try conjugates. You can try common denominators. Always looking to see when can I substitute in this x value that we're approaching, and hopefully evaluating to find the y value. If you ever get stuck, you can go back to making a table or a graph, and those strategies will work as well.